All right, for our last examples here, we're going to look at factoring as a method to solve. So notice factoring is never going to completely go away. We warned you at the first of the quarter, first of the year, know how to factor. Okay, so we're going to factor even without having x's in here. We're going to factor with cosine thetas and tangent thetas and all kinds of lovely stuff. But it's really the same concept. So when you look at this lovely equation, here's my equation right here. Here's my interval, but my equation's right over here. Notice there's only two terms. You can just see the 1 plus. So here's a term, the cosine theta, tangent theta, and there's a term. If there's only two terms, when they ask you to factor, all they want you to do is factor out the greatest common factor. Okay, over on our next one, we'll have three terms and we'll show you a different method. But on this one, all they're going to have you do is factor out the greatest common factor. So you're going to look right here at cosine theta, tangent theta, and then look at the second term, the cosine theta. What is the common factor? Well, that one's kind of obvious to see. It's just that cosine of theta. Okay, so we're going to undistribute or factor this out. Remember, what we're trying to do is when we make it so when we distribute or multiply this with something, we get back to cosine theta, tangent theta. So I've already got the cosine theta, so I'm going to need to multiply that with the tangent theta to get back to my cosine theta, tangent theta. All right, now I need to find something that if I multiply with the cosine theta gives me the cosine theta. What do you multiply cosine theta with to get cosine theta? Just 1. But don't forget that. Don't just leave it off, because then you only have cosine theta, tangent theta, and you can't solve that one. Okay, so don't leave it off. Put that 1 in there. Now, what this means is that you now have, by factoring, you now have a product. You have two things that multiply to give you 0. And we've got a really cool property, the zero product property, that says that if two things multiply to 0, that only works if 1 is 0. So it would work if this cosine of theta is equal to 0. So we're going to set that equal to 0 because 0 times anything is 0. But it would also work if this tangent of theta plus 1 is equal to 0, because 0 times anything is 0. And then you just go through and solve. Now this one's already solved. Cosine theta is equal to 0. It's already solved for my cosine theta. Over here, to get my tangent of theta together or by itself, I just want to subtract 1 from both sides. So I know that my tangent of theta is equal to -1. All right, now it's no different than our the last few examples. We're just going to look on our unit circle now. Again, look at this interval. It's from 0 to 360. This time we want to give our answer in degrees. So all the way around the unit circle here, we're looking to see where the cosine is 0. Cosine is your x value. So we're looking to see where x is 0. Oh, there's one. 90 degrees for that one. Keep looking because there's probably another one, and there is, and I can't see it here. Let's move this up a little bit. All right, now can you see it? There it is right there. Whoops. Pens, blue. So there's my x is 0, so it's also at 270 degrees. And then also look for where your tangent is a -1. Okay, again, hopefully you have these tangents written down. I'm not going to write them all down here, but there's a -1 right here for your tangent at 135. So 135. And then there's also another -1 over here at 315. So this one has 4 answers. There's 4 angles that have either the cosine of theta being 0 or the tangent of theta being -1. All right, let's try this last one. This one is the same type of question. We're going to factor. Oops, this one might not work as well because I've written all over here. Let's see if we can make this smaller. All right, we're just going to play with what we have here. We're going to try our best with it. Whoops, that's not working. Okay, so let's look right here at this next problem. Pens, let's do red. So we're going to take this lovely equation right here. I'm going to write it down out here. So we've got this 2 cosine squared theta minus 5 times the cosine of theta, and that's equal to 3. Now, this is what we call quadratic in nature. Some of you were here in class last unit. I talked a little bit about how notation. So when you have the cosine of theta, if you want to square this cosine of theta, like if you want to square it, they actually don't write. It's not the same as writing the cosine of theta squared, because that's just the angle squared. So it's not going to be the same. But instead of writing it like this, they didn't want to always write parentheses. So they came up with another notation that they just write it as the cosine squared of theta. So when you see it like this really just means that cosine of theta squared. Okay, so it's the same type of thing. So when you're doing this, I kind of would say we can use like a little bit of, we call it u substitution, but you can even just think of this as an x squared, okay, or an x right here. You're just going to kind of think of those and think of it as a quadratic function right here. So when you're solving a quadratic function, when you're solving by factoring, we always have to have it equal to 0 first. So we're going to subtract that 3 from both sides. And we have the 2 times the cosine squared of theta minus 5 times the cosine of theta minus 3 is equal to 0. All right, so this lovely equation does not have any common factors. Notice they both have cosine, but that doesn't have cosine. This one's divisible by 2, divisible by 3, 5. So there's no common factors. So when we go to factor this, you guys will love this. These are your guess and check from a few units ago. Basically, what we're going to do is we're going to make it so our first terms here multiply to that first term, to 2 times the cosine squared theta. And 2 is a nice number because there's only 2 numbers that multiply to 2. The only numbers that you can multiply are 2 and 1. So those are the numbers we're going to plug in. But again, remember we want it to end up to be cosine squared theta. Or remember that cosine squared theta is just cosine theta multiplied by itself. So we're going to give each of these a cosine theta. That way, when we multiply them together, it gives us that cosine squared right there. All right, and then you're going to look at the last right here. You're going to say, okay, there's only also 2 numbers that multiply to 3. Our last terms here have to multiply to the last term. So you're just going to say, well, 1 times 3 are the only numbers that multiply to 3. However, you do have to check this because this one is one that, yes, there's only 2 that multiply to 3, but depending on where we put it, this answer is going to be different than if we put the 3 over here and the 1 over here. So please don't forget to check it. So remember, when we check it, we've already checked the first term. So we're going to check these outside terms here. 2 cosine theta times 3. That gives us a 6 cosine of theta. And then check the inside terms. 1 times 1 is just 1 cosine theta. And then you're going to say, look at the sign right here. They've got to multiply to a negative, so they've got to be different signs. Can I subtract these numbers to get a negative 5? Well, yes. If I have a negative 6 and a positive 1, then that will work out. So I guessed correctly. If you didn't guess correctly, just go switch those orders or switch a sign and you can have it fixed right there. So we're going to put a minus right here because that negative 3 multiplies with the 2 to give us the negative 6, and put a plus right there. All right, so now we have our factors. Now these are multiplied to give us 0. So again, just like we did over here, you're just going to take them individually. Either one of them could be 0. So you're going to set them equal to 0. So say 2 times the cosine of theta plus 1 is equal to 0, and solve that. And then 1 times the cosine of theta minus 3 is equal to 0, and solve that. So let's look at solving this one. We subtract 1 from both sides. I have 2 times the cosine of theta is equal to negative 1. Divide by our 2. So I am looking to see where is the cosine of my angle, negative 1/2. Okay, let's finish out this one before we go over here. So look on your unit circle, and I'm going to scroll up here a little because my interval I forgot about. So the interval is between 0 and 360. So all the way around the circle, I'm looking for an x value of negative 1/2. So x value of negative 1/2, oh, there's one right there. So I'm going to say 120 degrees. Okay, keep looking for an x value of negative 1/2. There's another one. So we're also going to say 240 degrees. And then we're going to come over here and solve this one. I'm going to say, okay, if we add 3 to both sides right here, cosine of theta is equal to 3. So when we grab our unit circle to see if there's any 3's around here, there are not. This is what we call an extraneous solution. So watch out for these. Sometimes the numbers are not on our circle or in our interval. In this case, you can never have a cosine, or sine for that matter, that's greater than 1. Because remember, the cosine is the adjacent over the hypotenuse. So if you divide by the biggest side or the hypotenuse, you're always going to get a number smaller than 1. So we're just going to cross that out, say that's extraneous, and we're going to use those 2 answers as our answers. And that's it. Happy homeworking.